Hi, in this Let's Create series, we're creating the classic Simon memory game, where you have to remember the sequence of lit blocks. In the last episode, we created a dynamic grid of tiles of arbitrary size. In this episode, we will focus on adding light and sound to each of the light presses and creating a menu animation. Let's get started. The first thing we want to do is get the lights flashing when you click on them. You may want to play around with how long the light and tone play for, so we're going to add that as a changeable variable. In the GameManager.cs, in our variables at the top, we'll add a new header called Audio Setup. For now, we're just going to add a serialized private float called Duration. I'll default this to 0.2, as we probably want the lights to flash quite quickly. Whilst we're here, we'll also add the using system.collections. We'll need this for our coroutine that we're going to use to flash the light. Let's implement that coroutine now. This is going to be a private enumerator called flashTile. This method just takes one parameter, which is an int called index. This will be the index into the tile array for the tile we want to turn on and off. So all we need to do is simply call the turn-on method on the tile at position index, which will light up our tile. Then we want to wait for our duration so it stays on. For this, we use yield return new, wait for seconds, and pass in our duration. So after 0.2 seconds, our coroutine will carry on executing. And at that point, we simply want to turn off the light. We just need our action of clicking on the tile to trigger this coroutine. So we'll create a new public void called play light and tone, which takes in the index of the tile. And for now, we'll just simply start the coroutine we've just made. This is a public function because we want to call this from the tile in the onMouseDown method. In fact, let's add that in right now. When we created the tile.cs script in the last episode, we added this call within the onMouseDown, but we commented it out as we hadn't written it yet. But now we've got the simple implementation, we can just uncomment it. Let's jump back into Unity and test out the flashing tiles. When we click on each of the tiles, it says lit up briefly. If we open the GameManager object, we can see that if I lengthen the duration, they stay on for longer. But I quite like the quick flash, so I'm going to leave this at 0.2. Now we have the light flashing, we also want to play the tone. The first thing we want to do is import our sound. Create a new directory called audio, drag in the audio file we are using, and this sound example is linked in the YouTube description. This is called 440 because it's a 10-second clip of the 440 Hz tone. I'm using a tone because I want to be able to play with the pitch of this tone in order to create the unique sounds. The alternative is to create an array of sounds which you assign to each block, but I'll leave that up to you. Whilst we're here, we'll add an AudioSource object to the GameManager. This is what we'll reference to play the sound. Make sure to uncheck play on awake, as we don't want the sound playing until we click a tile. We can then drag our 440 Hz tone into the audio resource. Back in GameManager.cs script, we want to get a reference to this audio source so we can play the sound at will. I'll add a new serialized private audio source variable and call this AudioSource. This way we can set this in the inspector. You could equally have acquired the reference using getComponent, and that would be equally valid. Now we can create a method to play our audio source when we want. So create a new private void called playTone, which takes in our tile index. We're passing the index because we want to vary the sound for each tile. As I mentioned earlier, you can add lots of different audio clips and play a specific one for each tile. However, as I wanted the number of tiles to be any number, I chose to do this tutorial where we'd modify the sound rather than having distinct ones. To do this, we're going to adjust the pitch of the tone to make a unique sound for each tile. The pitch belongs to the audio source, and we can access it using the AudioSource.pitch. If we set the pitch to 1.0, this will leave the sound unchanged. To get a variation of tones, we want to change it between, say, 0.5 and 2.0. That way we'll have a bunch below and a bunch above the bass tone. We can do this using MathF's lerp method. This stands for linear interpolation, which is basically just a built-in way of calculating the position between 2 points based on a past percentage. So we just need to pass our percentage in. This should be 0 when we're on our first index, which will be 0, and 1 when we're on our last index, which will be numtiles minus 1. To get this, we can just divide our index by numtiles minus 1. The 1 here is a float because otherwise this would be an integer division and we need it to be floating point. If you only have one tile, this won't work because you'll get a divided by 0 error. But it's always worth, when you're doing things like this, to put guards around this or ensure the number of tiles is always bigger than 1. In this case, I'll solve that by putting this pitch change inside an if statement that ensures that the number of tiles is bigger than 1. If it isn't, the pitch will not change and will just pick up the default pitch on the audio source, so that's fine. Now we've adjusted the tone, we need to play it. There are various methods to play the tone. I've made it slightly complicated for myself by having the requirement that I only want to play the sound for a specified duration. If I had created the tone with exactly the right duration and didn't have it as a variable in the application, this would be simpler. But even so, this highlights a nice utility of the audio source. The way we achieve this is by scheduling the sound to play at an absolute time on the audio timeline. We don't actually want any delay, so we'll create a double called current time, which we set to the audio settings.dsp time. This is just the current time on the audio system. Then we can tell the audio source to play this right now using play scheduled and passing in the current time. If you were creating a music app and you wanted the sounds to all play on a strict beat, this is how you could achieve that, rather than trying to do it in an update loop which could vary. We then just need to say when the sound will end, and you can do this with set scheduled end time. For this, we simply pass in our current time plus duration. So it will stop playing the tone after our duration. That's it. We can now add the play tone call into our play light and tone method above after we've started the flash tile coroutine. Jumping back into Unity, the first thing we need to do is drag on our audio source to the reference in the Game Manager. Then we can hit play and check that the sound now plays as we click on the different tiles. That's cool, it seems to be working, and if we click on all the tones in order, we can hear the varying tones we've created. Okay, we're very close to creating the game logic. Before this, we'll get the game state set up. So back in GameManager.cs, in our variable definitions, at the top, we'll add an enum for the game states. We'll add an enum called game mode, and this will hold each of our states of the game. In here, we'll have none, menu, listening, and playing. We'll use none for when we want the user to have no ability to interact with the game. The menu state will be when we're waiting to start the game, and we'll have the lights flash randomly. The listening state is for when you're watching the sequence we have to repeat. And finally, the playing state is for when you have to enter the sequence. Then we'll create a private variable of type game mode called game mode, which will default to none. You can probably get away without a none state in this game, but I think it's a good practice to have it in there. For the rest of this episode, we'll add the menu animation, and in the next and final episode, we'll do the game mode. So at the end of the start method, we'll set the game mode to menu. This makes sense, so when we start the game, we'll be in the menu. Then we'll want to start our flashing tile animation off, so let's create a coroutine for that now. So the coroutine is of IEnumerator type, and we'll call it menu tile animation. For this, we'll simply light a random tile by calling our flash tile coroutine. When in a coroutine and we want to call another coroutine but wait for it to finish, you use yield return and then call the coroutine. We need to pass an index to the flash tile coroutine. As we just want it to be random, we can use random.range between 0 and num tiles. Note that when using integers in range, the upper bound isn't included, so this is correct. The coroutine turns the light on, waits duration, and then turns it off. So before we light the next light, we want to add another pause. Add a yield return new, wait for seconds, passing in our duration to wait before the next. Okay, that will flash one light. We want to keep it going. So we'll wrap that whole thing in a while loop. So while the condition is true, we'll be flashing the lights. The condition we'll use here is game mode equals game mode.menu, which means that this will keep going until we change the game mode or we stop the coroutine. Now we've added that, we can call it using start coroutine at the end of the start method. So when the game starts, the flashing lights start. Back now in Unity, if we hit play, we should see the menu tile flashing animation. I think that's looking really good. We've not stopped the ability to click on the tiles yet, so you can still press them and hear the sound. We'll fix that up when we update the tile clicks to work with the game logic. That's it for this episode. In the next episode, we'll add the play button and introduce the call game logic. As ever, the full code is on GitHub and linked in the description below. See you next time.